Hi everyone, good afternoon. So today's topic in hand will be Terraform, Terra's Tamed, a GitOps tale with KCL magic. Who am I? I'm Pratik Singh. I'm a distribution engineer at GitLab. By the name distribution engineer itself, I know it seems a little bit confusing, but basically what my job role is, my team provides Terraform scripts, Ansible scripts, Helm charts to install GitLab on your own premises. That's me and my team behind it. You can scan this QR code if you want to connect to me. And without any further ado, let's get started. Today's agenda is very simple. I'll keep it as simple as possible. We'll talk about the problem that we want the solution for. We'll talk about the solution itself. I'll talk about the workflow. I'll show you the demo. And lastly, we'll end up with challenges. And at the last 5 to 10 minutes, I'll give you for Q&As. So let's understand the problem. In today's world, standing in 2025 in front of all of you, each and everyone wants to be everything in the software development cycle. Every front-end engineer wants to be a DevOps engineer. Every DevOps engineer wants to be a back-end engineer. And somewhat it's okay, somewhat it's not. Now, how many of you know infrastructure as code? Infrastructure as code? Yeah, obviously. Everyone knows infrastructure as code. So the problem with infrastructure as code is not bad. It's really good. It's a very good concept. The problem is when infrastructure as code is clubbed with automatic tools that just implement anything that is pushed onto a Git repository. Has anyone of you heard about Atlantis? Has heard about Argo CD? Argo CD you guys have heard, right? So Argo CD is for YAML files. Atlantis is for Terraform files. The problem is that if a developer goes ahead and pushes a Terraform script, Atlantis or similar tools goes ahead and applies those changes. Now, at this point, I think you can understand when infrastructure as code clubbed with GitOps, the problem is that monitoring and policing and restricting the usage gets very difficult. At what point do you draw a line who has access, who does not have access? What resources has to be built, what resources has not to be built? If a resource is needed, in which region is it needed? Is it 8 GB of RAM? It is 4 GB of RAM? Does it need storage? Does it not need storage? There is a lot of manual work when it comes to infrastructure as code, right? I'm pretty sure if you have worked with developers, they always have an opinion that, give me the infrastructure or the EC2 instance as early as possible. Just provision the VM for me right away. And with the tools like GitOps, it's really easy to do that, right? But again, the problem, as I was stating, you don't know the resources. At what level, at an organizational level, if you think, where do you draw the line that, okay, this is where I need to check everything, right? Coming to the solution. Now, imagine if there is a place where you as a DevOps engineer writes all the policies where you state that, okay, any resource that is built has to be in this specific region, has to be not more than 8 GBs of RAM, has not to be more than 4 GBs of RAM, has not to be this kind of database, T3 micro, T2 micro, anything like that, right? Now what happens is that if you have something like this, you as a DevOps engineer can be very easily sleeping in your home while anyone else makes changes to the infrastructure. You are sure they are abiding by the rules or the policies that you have set up, right? This is where KCL language comes into play. What is KCL language? KCL language is a CNCF open source project. As of now, it is a sandbox project. What it does, if you can read it, codify and manage your modern configurations and policies. It supports Kubernetes YAMLs, it supports Terraform, it supports Ansible scripts, it supports Argo CD and whatnot. This is a language which is pretty much new to the world as of now. But with the use of this language, today we'll see how easy it is to monitor all the infrastructure code changes in our demo, right? If you guys want, you can scan this QR code. You will be redirected to this repository. So this is a repository that I made specifically for this talk. This has all the demo, all the codes, everything that is needed for today's demo. So let's see a KCL file. How does an KCL file looks as of now? In today's demo, we'll be just limiting our scope to see if an infrastructure, a Terraform script that has been sent to us is trying to create an EC2 instance which is out of US East 1. I'm not going to explain the whole KCL language because that is out of the scope of this talk and it will exceed a lot of time. But if you see this particular line from line number 11 till 13, so this particular line if you see which is highlighted in front of you, what it is checking is if the Terraform resource that the Terraform script that has been pushed to your Git repository, is it an AWS instance? And if it's an AWS instance, is it available if the availability zone is only US East 1? Why US East 1? Even I don't know. A lot of each and every company have loaded US East 1 with their resources. But yeah, for the purpose of demo, we'll keep it US East 1. Okay. So coming to the workflow, what we'll do today. What I have built in this demo is that I have created a GitLab CI pipeline, which basically takes up any Terraform code changes that is pushed to the repository. It validates the thing, it plans for it, it checks if the Terraform script that has been pushed to it, does it follow the KCL policy that I have implemented or not. If it implements, then it applies it. If you see all these three, I will be showing you the code as well. All these three are dependent on each other. So if the Terraform validate fails, the other two will not work. And same goes for plan check and apply. At the end, if you see, there is a destroy button also as well, which I have created. That is just for the sake of the demo. You have to manually trigger it. Let's get into the good stuff. So wait, let me zoom this. Can you see this GitLab CI file at the back? Yeah, nice, thank you. So as you see, there are 4 steps. I have kept the AWS default region as a variable just so that I could have done it with different purposes. Now understand that this demo that I am representing in front of you, please don't take in any aspect that it is only limited to GitLab. You can do it on any code repository that you want to do. You can do it on GitHub, you can do it on Bitbucket, it is up to you. What is being done, that what matters over here. So we all know that a CI/CD runner is basically an immutable machine, a new laptop that comes up, a new PC that comes up. You set it up and then you say that, okay, run these XYZ commands. So if you see, what we are doing is, we are first of all installing Terraform over here. We have Terraform working till here. We have the AWS keys supplied because the pipeline itself will be applying these AWS changes, right? And then we are just starting the Terraform thing. Now, if you see the Terraform validate step, why is a validate step needed? Just because I don't want anyone to make a syntax error in the Terraform scripts and my whole pipeline should run for it. That would be a waste of resources and that's what I don't want to do. Right. Comes to plan and check. So this is where it is important. If you see, what we are doing in this is, we have the Terraform plan script, plan command running. We are taking the plan command in a tfplan.binary. Why binary? I'll show it in the next step. We take the binary, we store this as an artifact in the GitLab repository itself. Then we install KCL. Now the point is that these commands that you see, as I was mentioning, can be run from your own machine. It can be run from any other Linux setup that you have. We install KCL, now this is the main command. What it is doing is, it is checking that whether this policies.region.check file is being applied or not. I'll show you in the demo how it is working. Now once this command runs successfully, we go to the next step. It's basically just applying the the Terraform plan, and destroy is a manual step. Okay. Now let me show you a demo because if you want to see the exact logs, you can scan the right one, that would be redirecting you to a pipeline where it shows the failure logs, where you can read up that why exactly that file is failing. Whereas on the left is a successful pipeline which will show how it works. I will show you this on my system. Okay. So if I see what was the file that was pushed, what were the changes that was pushed in this. So you see in the main.tf, what has the user done? He is trying to push something in the US2 region, right? Now suppose I am a country, if I am a company, an organization who does only stuff in US East 1. Now the developer is obviously trying to provision an infrastructure, provision a resource which won't be used by other resources. In that case, what does the pipeline do? So first of all, because the Terraform file was correct, the syntax was not a problem, it did pass the file. Now let's check into the failures. What does the log say? So this is just installing Terraform and KCL and everything, right? The Terraform plan will work, right? Why will it not work? Because according to Terraform, there is no error. According to Terraform, it is saying that yes, US East 2 is a valid answer, and it is applicable in the case of AWS. So now here comes, so this is installing KCL. Now here comes our KCL command if you see, line number 668 if you will see. What is this saying? This is saying that it checked for the resource changes. What were the changes done to this Terraform file? Since it is an AWS instance and the availability zone is not US East 1, the command specifically tells us that AWS instance resource, the name of the instance was web, must be in region US East 1, but the availability zone is US East 2A. That is why this pipeline was failed by KCL. Now, by this failure, you do understand that the scope of this can be exceeded out of region. It is not basically onto region. You can go it for suppose databases. You can go it for what kind of database, which version of database. You can also check that whether it's an S3 bucket, then which kind of S3 bucket, what should be the availability zone of that S3 bucket. Now, just before the talk, just before an hour ago, I was checking for this a successful log, right? So what did I do? I did not do much changes, but I did run this pipeline. Now, I will not go to the top, but you see at this point, what I did in this commit was that I did make it to US East 1. Since the Terraform script as of now, if I can show it over here, the current Terraform file has US East 1 written, right? In that case scenario, what it is saying that validate was successful, and on my AWS instance, on my AWS, you can see there is an instance running for the past how many minutes? 1 hour. Oh, okay, last 39 minutes ago. Correct? So we did see a failure log, we did see a success log. How does KCL can be used? This is an exact demo. The KCL policy that you are seeing, I'm definitely sure that you will not find it on the internet because I had to write it myself. Which brings me to the challenges of this approach. So in DevOps, at this point that we are standing, everything has to be declarative. Everything is a YAML file. We have moved past an language-based approach. We are not using Ruby anymore. We are not using Bash scripts. We have moved to a very specific declarative language that whatever I have to do, I will do with a YAML file. If you use KCL, the very first problem that KCL is tough. You will have to understand and learn how does a schema work, what is a configuration, how do we change it, how do we apply KCL, right? It is an added workload to your team. Why it's an added workload? Because your team will have to learn KCL, they will have to implement it everywhere. This technology is still pretty new. It is a sandbox project as of now. It was launched in 2023, at the end of 2023, I guess, so not even 2 years till now. Then you need precision with the requirements. Why do you need precision? Because if suppose you as an individual go ahead and say that, you know, I will not allow any team to build a EC2 instance more than T3 micro, but there is some another team that needs a T3 micro. Now that is why I was saying that you need a precision of this requirements. What are the benefits of KCL? I would like to add it over here. KCL is very modular in its approach. Whatever policy you write once, you can use it in multiple places. If you have introduced KCL in your workload, one benefit that you get is KCL, as I showed you, it's not only limited to Terraform scripts. If you write a policy for Terraform in KCL, you can rewrite it with a little bit of work in YAML file. You can rewrite with the same with Ansible script. So whatever way that you are doing infrastructure as code, KCL can come in and monitor those changes, right? I think that's about it from my end. You can scan this to get all of my credentials. Any questions at this point?